In this section, we will talk about measures of variation. Besides measures of central tendency, we may also be interested in variation. For example, consider these two samples. Sample 1 has the observations 4, 5, and 6. Sample 2 has the observations 1, 5, and 9. Both samples have the same mean and median, but sample 2 has a much larger range than sample 1. To measure variation, we use several statistics: range, variance, standard deviation, and coefficient variation. We have discussed range in Chapter 2. The range is defined as the highest value minus the smallest value. However, the range is very sensitive to the outliers and ignores the distribution of values. Think of how different the histogram would be for these two sets. To account for these distributional differences and to minimize the impact of outliers, we use the measurement of variance. The variance is the average squared deviation from the mean for each observation. Remember that x bar is our sample mean, so we are asking by how much does each value deviate from the mean. That is what the variance tells us. One drawback of the variance is that it is measured in squared units. For example, if we want to know the variance of commuter distance traveled in miles, the variance would be in squared miles. However, our data would be in regular miles. A standard deviation is a measure of variance that uses the same units as the original data. It's easy to calculate, and it's only the square root of the variance. Steps for computing standard deviation. Step 1, you have to calculate the mean. Step 2, you have to compute the difference between each value and the mean. This is shown, we'll show this in the next slide. Step 3, you have to square each difference. Step 4, you have to total the squared differences. And then step 5, divide this total by n minus 1 to get the sample variance. Finally, step 6, we take the square root of the sample variance. Here's an example. In the first column, I would place my sample data from lowest to largest. Next, I calculate the mean and place that value in the second column. Third, I calculate the deviation from the mean for each observation. For the first value, it is 10 minus 16, which would be negative 6. Fourth, I square each value and then take the average to find the variance. Finally, you take the square root of the variance. In this case, our sample standard deviation would be 4.31. Here are 3 different samples that have the same exact mean, but as you can see, the data are spread out differently, and this is measured by the standard deviation. You can see that in this first one, the data are spread out all over the place, so the standard deviation is 3.338. In data B, the data points are much tighter, closer to the center, so the standard deviation falls to 0.926. And in the last version, which is the extreme version, all the data are actually in the tails and nothing's in the middle, and that has the largest standard deviation. Smaller standard deviations indicate that the values are closer to the mean, and larger standard deviations state that the values are farther away from the mean. In summary, the more data are spread out, range, variance, and standard deviation increase. The more the data is concentrated, range, variance, and standard deviation decrease. If the data values are equal to each other, range, variance, and standard deviation are 0. None of these measures are ever negative.